Hi everyone, welcome to this bootcamp. This bootcamp is all about Internet of Things and an attempt to familiarize all of you with opportunities and landscape of both innovations and jobs and other things that are practically possible because of advent of Internet of Things. So we're going to cover a lot more about Internet of Things and how it's actually shaping up more or less every part of business and life we are actually working with. You can make use of what you hear from now in your own journeys of IoT Innovation Challenge, as well as anything else you would like to really learn, adopt, and make it part of your career. Let's see what is this Internet of Things and how it's actually shaping several things around the technology and business domains of the world. So there are a lot of reports, a lot of analysis, and varieties of information available on the size and scale of Internet of Things and opportunities associated with it. We will not dwell too much into those numbers, whether those numbers right or wrong. Let's assume that even 50% of what you see as data is right. There's a huge amount of opportunity for everybody to really make use of. So our idea here is to really make sure we look at these opportunities as opportunities for a technology student and then shaping into a technology professional. So that is how we look at it. So given the number, size, and scope of what IoT or Internet of Things is possible to do, where is my opportunity? I think that is where we all have to really look at. So that is what we call spotting. Spotting the opportunity becomes very, very critical. And we look at how to spot and how we can actually make use of some of those opportunities very well slated for what you would like to do as your career. First of all, let's see what makes Internet of Things, or more aptly put, Internet of Everything. So there is a reason why we say Internet of Everything, because everything, every object, everything you actually want some control or access over can really be made smart. So what really makes Internet of Things? So simply put, there are four key elements of Internet of Things. One element is the unique ID. The unique ID, or identifying a thing very uniquely in several billions of things like that in the world, right? So identifying becomes a very key element of Internet of Things. Second element is sensing. Some ability to really sense, some ability to really figure out what's going on around and make sure that that sensing that is done is useful for an action is the second element of it. The third is, yeah, I have a unique ID, also have some sensing capabilities, but I need to be communicating with somebody else remotely, more or less, to make sure that that action can be taken either by the thing itself or by somebody else who's actually monitoring or controlling that thing. So that's why the communication becomes the third element, which is very, very critical. The fourth element is autonomy itself. So to get to an autonomous thing, you actually need ID, sensing, communication, and a lot of intelligence built into it so that the thing actually becomes autonomous in its own way. So if you really look at, let's see two different examples, right? One example is, take a autonomous car and associated activities that are going around the world. All these autonomous cars, right, they actually are identifiable. You can really identify one car that is out there, right? And they have huge sensing capabilities in themselves. So they have multiple sensors which will actually help them find what is around them and also help them navigate with themselves. But they also have a lot of capabilities for communicating across cloud, and with the help of varieties of analytics that are practically possible, they get the intelligence to take action on their own in real time wherever they are. So that is the autonomy part of it, right? But if you really look at simplistic applications like want to go to a conference room, and in that conference room, you want to know that is there any seat available at all? That may be as simple as that. So you don't want to get into a kind of a conference hall where there are 100 seats and 200 people going in. If that is the situation, you can actually enable that also with something like this, right? You have a unique identifier for all the chairs there, and you have sensing capability for the chair to really see whether it is occupied or not, and the ability to communicate back to a particular server or a mobile app, whichever way you would like to see, wherein you know, okay, so there is this particular seat available and vacant, and you actually can take an action, or you can block it and then enable it to say that, okay, this is blocked for me, I will come and take over. It can be as simple and neat as that as well. So you can imagine any business situation or any process, any problem situation wherein you would like to identify things in unique fashion, give them sensing capabilities, and be able to communicate over air, then make sure that they take action or they allow you to take an action. So the four elements that make Internet of Things are these four elements of it. But they are backed by the superpower of the what we call SMAC, or a social mobility analytics and cloud. The cloud and analytics play a very significant part in making Internet of Things what they are today. Wherein mobility, as we all know, mobile devices are the best example for an Internet of Things device, which actually connects to internet, does a lot of things on its own. At the same time, it can help you do a lot of things, and that can be a good channel for accessing every other thing you make or you want to make it smart enough. So primarily, if you're talking about Internet of Things or Internet of Everything, we have to worry these factors. Okay, how do I identify it uniquely? What sensing capabilities are required? How do they communicate? Be it GSM, be it Wi-Fi, be it Zigbee, whatever kind of communication mechanism, and some amount of action taking. So without an action either on its own or by somebody else as triggered, I think the smartness will go away. So that is supported by social mobility, analytics, and cloud part of it. So these make Internet of Things or Internet of Everything. So what, right? So anything can be made smart with the help of these four elements. Then what happens is, if we see our planet is already occupied with several things. We have anyway from animals like cow to every other device we have actually built and put it to use. So be it energy, be it auto, be it industry, you know that all our universe is flooded with quite a bit of things that are already there. So we call them as legacy. The reason we call them legacies, they are there from the beginning of this IoT or otherwise. So the ability of IoT is to really help us make every one of them, if we want, become smart enough. The way to do it is, yeah, so I need to identify where the bulb is in my home, identify this particular device, or at least this bulb, and make sure that, okay, I can sense there is a power or not, current or not, or occupancy of people around there or not. Then according to that, send out an information back to a server or an edge router there to make sure that, okay, this bulb glows, switches on, switches off, or dims, whatever is required. You can actually convert these legacy devices into a smart devices with the help of what we call Internet of Things, which are nothing but the four elements we talked about. So that's a beauty it provides. So what is the opportunity? World is populated with billions and billions of things, and many things actually would be very, very useful to have them smart in the sense that either they take action on their own, or we as human beings are able to really take actions the way we would like to. So to make that happen, we need tools, we need technology, we need methods. That's what actually is presented by IoT, and that throws a lot of opportunities, because legacy modernization itself is a huge business waiting to happen. And you can imagine things around you, be it your motorbike or computer or agriculture implants, whatever. You want to really find out where they are, it actually takes a good amount of physical effort to do. And if you are in remote places and you would like to either secure or know where they are and what you would like to do, it may be very useful to have one of these IoT devices connected back to that in a very stealth fashion, which actually gives you an ability to really track, find out, or do something about anything that is there around the world. So that's kind of an opportunity IoT is presenting to a lot of people to really make everything around us smart and maybe intelligent as we go forward as well. Right? So as I said, this is not a very technology boot camp, because we want you guys to really understand and apply the technology to a business particular problem you're trying to solve with IoT. Still, I thought, okay, I'll cover what makes IoT from a technology architecture point of view. So as you can see, IoT is actually can be classified as a 7-layer technology architecture out here, with very specific elements of 4 or 5 key elements that are important. If you look at, we need hardware, we need software, we need communications, we talked about it. And since this is over air and internet and everything else, security becomes an important element of concern. So security is another item out there. So if you really look at it, hardware is the fundamental backbone of all this IoT. So hardware today is matured a lot. So matured to a large extent wherein you actually have either open boards which are actually available for you to customize the way you would like to, or there are do-it-yourself kits which actually will give you a lot more abilities to really integrate several sensors, several communication hardware, actuators, everything else into one. Or go a traditional way, you actually can go and build your own hardware board, be it with a processor or microcontroller based system, to really make sure that, okay, it actually satisfies the need that you're going after. The choice here is to really figure out where you want to apply. For that particular application, you have to make a choice of what kind of hardware you're going to really go forward, what kind of communication you would like to make use of, what kind of software that will be required for it, to make sure that you have that application possible for anything that you would like to work with as well. Because lifestyle, if I take as an example, so you might have heard of bands and wearables like Fitbit. So they are kind of small wristbands actually put on your wrist, which apparently can track several vital signs in your own system, your own body. And they actually make sure that they use sensors that are relevant for human beings, communicate as the way it is required, either through your mobile phone or otherwise, have enough software required to really make sure that they sense, they communicate, they take action, and actually report back to you or show it to you. So by making choice of which problem you want to solve, what you would like to build, you have to make a choice of what kind of hardware, what kind of communication, what kind of software you really need to build upon together and integrate it well enough to suit the requirement. As I said, the foremost element today, since they're all exposed to internet, there is that threat of security. At each level, there are securities possible. So depending on what you do, say if it's a lifestyle application like a wristband, as I said, you look at with sensors and everything else, you make a choice. Similarly, you have to make a choice of security as well. So how do you really make sure that the wristband you are wearing is actually only for you? So there are authentication mechanisms to follow, there are security mechanisms to follow, there are privacy issues to follow, and everything else. So end of the day, what happens is, like any other technology piece, we can conveniently form IoT also for a different layered approach. The reason for that layered approach is to make sure that it is easy to adapt. At the same time, it is easy to expand and go further. So today what happens is, as I said, you have choices of hardware components possible as do-it-yourself kits and several starter boards. Several companies actually provide you starter boards as well. And at the same time, you have to make a choice of whatever data link protocols you want to go with, depending on the kind of communication level you go with. But there are IoT platforms available as well, both the paid as well as open source platform, which actually help you integrate the hardware and the communication capabilities into the application you would like to build. Okay, since they are communication devices, as I said, okay, you have network device management and other software components required to make it work. All of that can be even available in typical IoT platforms. So there are standard platforms, there are open source platforms, there are paid platforms available. But as I said, to start with, you need to really look at what are you really trying to work with. Is it a consumer IoT application or a business IoT application? And what kind of problem are you trying to solve with IoT? Then go ahead and then define your own architecture of what is the hardware, software, and associated security mechanisms you would like to go with. So any technology solution required for an IoT kind of an application, irrespective of whether you want to fix a legacy problem of identifying a dustbin somewhere, or cow being actually gazed elsewhere, or a remote satellite monitoring, whichever the area you would like to work with, the technology piece, if you really bisect and find out, there'll be about 7 layers of technology you can really look at it. So when you are on your path to identify a problem to solve, first level, I think you need to really look at is, what is my architecture? What am I going to start with? Whether I'm going to really go with a standard kit available, or I'm going to build a processor-based system, what kind of Wi-Fi or a Zigbee or whichever wireless protocol I'm going to use, and how am I going to really make use of the software. Instead of me developing, I can actually take up something, integrate it together, and make the whole thing work for us. So that's how you actually process and proceed further when it comes to technology piece of this Internet of Things architecture. So that's fine, but as I said, the first and foremost is always the application domain. So what is the problem you're trying to solve? Where all can I really apply IoT, and how can I really apply? So if you really look at it, this picture actually shows you a kind of a landscape of opportunities or technology pieces where we're using IoT for solving specific problems. So problems can be either air pollution or a fire detection, or even structural health of a building that is there or a bridge that is there. Because you have a bridge and you actually don't know whether it is peaking out on the stability or the structural fitness of it because of the load or because of something else, or it is going to really last longer for the design. So you can actually monitor the health of a structure as well. Or you can really go with the radiation levels in a thermal plant or a nuclear plant, right? Or traffic congestion that is actually there, or electromagnetic levels due to radiations of mobile towers and everything else, or power generation systems, waste management, water quality, you name it. So depending on the problem you want to really solve, I think you can really go and then apply IoT as a technology piece to make it work. But the key here is how are we going to really do it, right? So anything you say, anything to start with is always hyperlocal. Say, for example, we're looking at this bridge, and in this bridge, we would like to know the structural health. The structural health means that you have to find vantage points exactly where you're going to really install a sensor, which actually monitors maybe 6-7 parameters that are critical to judge the health of the structure, and then communicate the same health of it to a particular cloud or a server application elsewhere, which then analyzes what can be the problem, compares that with the material strength and the age of it and everything else, and maybe notify somebody else saying that, okay, this is the problem that's going to happen, and even forecast what is the kind of maintenance required and everything else. So the beauty there is it is always hyperlocal. So where exactly am I measuring? Which bridge am I looking at, right? And then actually becomes the entire bridge. And then it becomes, okay, how do I compare the strength of this with another bridge elsewhere of a similar kind? And then you actually go and then remotely monitor, manage, communicate, and also take actions that are very critical for making sure that the health of the structure remains the way it used to be. So anything you take, always start with hyperlocal issue. It's like if you have a cut on a finger, you have to go rush for a band-aid, right? So that should be a problem. So hyperlocal solutions may look like, okay, I'm solving a very small problem. But if you really look at it, any small problem like this you solve, they actually have to be covered over a period of time. So hyperlocal to local to regional to the global level is actually where the whole applications happen. So earlier, without the IoT as a technology, if somebody figured out a problem here and they had a method to solve, they would have solved it on their own, either after they noticed it, after some breakage. So there was no way you could actually capture into the intelligence of the world to really figure out what can happen, or to come up with forecasting models and everything else, which actually help engineers to take action more proactively than reactively. So whatever we call preventive or mostly very innovative, predictable maintenance kind of mechanisms are all practically possible today, wherein you actually can have these kinds of capabilities into the things that are deployed, which help us really look at the data, analyze it, and either allow them to take action on their own, or we take action as well. So if you look at this piece of it, right, it covers the entire gamut of either a city or a country. Across that, how you can really deploy varieties of solutions using IoT and make sure that we address some of these things the way it is required for us to move forward with life. So that is the kind of domain applications that are actually possible with IoT as a technology piece, right? Where does this lead us to? So if you look at it, every element of where we live and how we live is getting connected. And they've been connected smartly enough, I think we'll get into most integrated way of life going forward. So take anything, right? So whether it is health or an industry or a city or a living or a working, anything you consider. So health today is not point health where you actually go when you have a problem, go and see a doctor and come back and do nothing about it. There can be several things that have been innovated today around health itself to make sure that it is more seamless, more efficient, more effective, because the entire value chain of health can be connected, can be interchanged, inter-exchanged, and also make sure that they are all working in seamless fashion for us to really survive on. So take an example of a connected car or any connected industry. So what happens for an industry, right from a supply chain to the consumption and retail of the product, everything is automatically connected, seamlessly exchanging information and data, and also actually satisfying each other's constraints and requirements. The industries can perform at the best level practically possible. Similarly, say for connected cars, right from a in-vehicle, what can happen to whatever you can really do for the next generation connected cities where electric vehicles may be one of the way to go. So in this whole landscape of things, if you see as an individual, student or enthusiast to really work at, we can take one simple thing. Say, for example, roadside assistance. So if we look at roadside assistance as a problem, and then say that, okay, if my car or a bike actually had some devices fit in, which actually track how I'm using, or at least even forecast the road ahead of me, whether it's good, bad, ugly, and then indicate that, okay, how I have to really avoid an accident is one element of it. But if there is an accident or something happens, how can it automatically generate alerts and also bring people for help? Either it is police or Medicare or friends, whoever it is. To actually design a system with IoT as a concept to really make sure that the roadside assistance happens pretty well. But if you go a little deeper, you can even cover one small portion of it also. We say, okay, yeah, it's an accident, but accident detection, how can I do? There can be n number of ways to really find out if some vehicle met in an accident at all or not. So if you work on those itself, you actually gather enough information, enough data, and a solution which actually satisfies exactly this piece of requirement, which then can be used by others who are building a complete roadside assistance solution as well. But if you look at a country or a company, they will look at the whole gamut of line out here as an opportunity for them. But if you look at each bullet out here, there's a huge opportunity. And within the bullet, there are several things that actually require, again, same seamless experience that is not available today. Which means the opportunity to really make use of IoT in any bit pieces out here is tremendous. And I think it's only the imagination of how we can apply this technology to a particular problem you notice is important. I think is what actually going to make a big difference there. But if you really look at it from an opportunity landscape, any dot out here, any connection within the dot is actually going to throw a lot more opportunities for everybody to work on. So is it really possible for one company, one set of people, one group, one country to do everything? It's impossible. So there is innovation possible in every area out here, and there is innovation happening around all these areas, and making sure that, okay, this actually become meaningful for a particular industry or a society to work with this as well. So this is how the integrations are going to happen because of IoT, solving various other problems and getting into a level of opportunity landscape for everybody who's interested in out here. Okay, so if you really look at it, what does that lead to, and why do people actually look at making IoT as part of a solution for solving a problem? So there are 3-4 very key elements of driving forces that are critical. Okay, one force that has been used most of the time why people adopted or started adopting IoT is due to the efficiency factor. If there is no human intervention required or minimal intervention required from human beings, machines can operate on their own, and then the entire production network is actually built into a way that, okay, you have highest productivity possible. How the efficiency factor will play for an industry. So likewise, even if you would like to do a same job far better, simply if it is a repetitive job, it is always better. And extend that further, if devices and machines you are actually using can actually talk to themselves, then figure out what is required for them and do the job, it will be much, much better. So for example, there is a machine which actually requires some consumables, maybe lubricants or whatever for that particular machine to operate. If it actually can sense, figure out that, okay, there is a level of consumable is coming down, and given the production forecast that is also fed into the system, it knows that it can run only for next 3 weeks or so, And it also knows that, okay, it takes about 2 weeks of time to really order and get some lubricant back into the system. It can actually go trigger a purchase request on its own for getting the lubricant delivered on time so that the production won't stop. So the amount of efficiency this brings into a process industry, it's actually tremendous. So to make this, yeah, you can make that machine itself smart or intelligent enough with proper sensing capabilities, proper communication capability, and then connections and integration back into their supply chain system and everything else. Most of the things that are requiring manual intervention to really figure out what needs to be done, the machine can do on its own as well. So the amount of efficiency it adds in is beautiful, and it actually helps everybody to really benefit better out there. Similarly, the second element, especially if you come from an individual or a consumer perspective, experience that the whole solution with an IoT can provide is amazing. As I talked about the machine case itself, there is no need for people to really worry about, okay, what machine is there, not there, is the person has come in to really fill it, what is the production capability relative to what I have, all of that. If it is done seamlessly and automatically, the amount of experience gain you're going to have is amazing. Similarly, in the consumer side, if you see, if there is a variable that actually is tracking your health or your lot people health, and then actually reporting as well as triggering actions required based on their conditions, and making sure that the whole integrated system works very well for that particular individual, the experience can be really, really amazing. So, but the third and important factor is not just efficient experience. So, this technology adopted well can actually enrich and also empower a lot of people to do a lot more things than what they are doing today. So, it can be even a machine. So, machine was just running and doing something, can actually go and take care of itself. So, that's kind of an enrichment. Similarly, if you apply to people, be it healthcare, be it education, be it transport, anything that actually requires too many coordinations and varieties of parameters to be considered, all becomes very, very simplistic to use, and it'll give opportunities for people which hitherto was not been available at all. So the simplest use of technology adopted in a business science in actually a problem scenario which is critical can actually yield a lot more results. So this is why I say these are the driving forces that are really pushing IoT and IoT adoption across the thing. If you really look at it, right, in a societal scenario, it always the center of everything is people. Around them is what everything else is built. So IoT touches people, either health or any element that are important for them, education, training, skill, etc. To the entire industry, government, town, cities, commerce, everything for that matter. So each area actually is seeing its own opportunities. Okay, be it retail or a smart grid, smart roads, smart homes, everything. Right. So you have an opportunity to make anything which you feel is important to be smart and convert them to an intelligent integrated system. There is opportunity available. So if you are looking at problems to solve, you're looking for opportunity to explore yourself as well as build expertise, you can choose any of these rings and indicative data that is out here just as an exploratory. But if you go deeper, you will find areas where I think you can really start off and then make it work for you, right? But the interesting aspect of all this, beyond the industry, beyond the individual experiences and empowerment, is the opportunity this provides for solving some hitherto unsolved, very large problems. See, large problems like water scarcity, right? So, whenever we have several big cities in India actually have a huge water crisis. So, water crisis, we know what it actually can lead to. It is not having enough water to use. It can be many times having water but not able to use. It can also go to a level that we are not actually managing the entire availability versus requirements as well. So the issues may be very different, right? From contamination, distribution, whatever the case may be, right? So there are several issues. If there are systems that we build which actually help us track the entire life cycle of water, and also at times that are required, we actually have interventions that are critical, then I think we can solve this water crisis far differently. So IoT can help in that particular aspect. Similarly, are the cases like, so we have one doctor for 1,700 people in our country. So a doctor cannot reach, but actually you can make the connect between the doctor and the patient both by enabling the doctor to use technology as well as people to use technology to be bridging so-called right time interventions for whatever is critical at that point in time for the health. So right time interventions are possible only when triggers are automatic, triggers are actually very sensible in terms of what is the necessity at that point in time than just a intermittent readings. So that is the thing that it can actually help. Similarly, look at situations of traffic, the amount of traffic congestion leading us to lose a lot of money without we realizing it. So how do we solve this problem? If you actually have smart traffic systems, both in the city as well as in the car, and varieties of systems can be built easily as well as in an affordable fashion to solve some of these problems, which are hitherto unsolved. So likewise, power, likewise skilling, likewise agricultural yield, or anything to do with satellite communication, reaching to everybody else as well, etc. So these problems have been solved, but not solved into the extent the problems are. So there are a lot of unsolved problems like this who are very large plus lucrative. So using IoT as a technology, it actually gives you an opportunity to solve these things much differently, right? So IoT definitely presents an opportunity to address all these very large, lucrative, unsolved problems. Why I say lucrative is even if you would like to actually make a traffic problem work, amount of sensors, amount of devices, amount of infrastructure that has to be built to develop over a period of time actually presents good amount of opportunity for a country to really scale themselves up, empower people, job opportunities, and everything around. So anything around solving a large unsolved problem will be definitely lucrative because it actually is going to help a lot of other ecosystem things to come together and make it happen for that. So IoT really presents that kind of an opportunity here. That is all fine. So this looks as a great opportunity to work with. So if I have to personalize, what should I be doing? So I'm an engineer, I'm budding engineer, third year, fourth year. What exactly can I really do, and what is that I should be doing, right? So that is the situation where you need to start screening for opportunities, both to build your own skill set as well as build some solutions that actually will help you to show to the world also that okay, you are capable, and at the same time you have the right skills that are required for making use of IoT as a technology to a given problem, right? How do we look at it? Where do you start, right? So we talked about four key elements plus four supporting elements, right? You can any area there you build your skill, be it in the sensor level, be it in the communication level, be it in the autonomy level, or in the mobile analytics or a cloud kind of an infrastructure. It's a very element level. If you build capability, that will be required as well. But you can also build capability at a very good infrastructure level. Infrastructure, I mean, okay, how do I make a platform work? How do I build a platform which is essential for having all these devices to talk to? You can look at that particular part. Or you can build products that actually can go, which are using these elements we talked about for a specific problem. You can offer services, you can have integration capabilities, and you also have specific problems you've identified, and you have a solution which actually may be making use of some products as well as infrastructure and services to make it happen. I think you see a lot more opportunities out there. So the fundamental skills required are all or electronic skills or software skills. We saw the technology architecture little while ago. That actually defines a specific skill set required out here. But using them and making one solution or one product can actually help you give exposure to all these things. So that is why we designed this innovation challenge in a way that okay, you identify a problem, go figure out a solution, and then actually build a prototype which is demonstratable. So during this, you actually get exposed to all the elements, infrastructure, ability to build a product, and also a solution that actually can stick out and then say, okay, this is exactly how I'm trying to solve it in an innovative fashion. So you can make use of this opportunity that way to really ensure that, okay, you get exposure here, you build skills necessary, and then more than anything, you have a sense of a problem you're trying to solve. I think that helps a lot. And that's what you can do to really build that capability as well as a solution. So that's fine. I can solve a problem in any which way, but why with IoT? Right? So that is a very interesting question that you can ask. So should I really use IoT for every problem to solve? Thing is, there are varieties of solutions possible for a given problem. But you choose a problem when you choose a problem to solve it innovatively, you try to make use of what is available best at that point in time, and also make use of things that actually help you solve the problem more efficiently. So that is why I think IoT becomes a very critical element of it. Why IoT? See, if not IoT for all, I think IoT will be all over for sure because of the possibilities we talked about. Anything you do, right? Anything you think needs control, monitoring, or automation. I think that's where the IoT comes into play. So if these are three areas you look at, even as we human beings, if you want to really measure, really monitor how we live and how we behave, I think today there are a lot of point solution. You can actually have solution for anything you would like to cover in your system, one by one, and also there are a lot of integrated solutions possible as well. So IoT definitely is all over. Look at other examples like the one at the corner out here. So there are experiments that are going on actually having a sensor, complete IoT system, on more like a backpack of the bee. So when bees move around, they become the vehicles to carry or collect data, transfer it back to a system, which then can actually decipher what is useful and actually take action, be it weather forecasting, be it the forecast required for weeds, forecast required for anything that need to be done, and also automate other actions in the system to make it work as well. So you just can't escape being a user of IoT going forward with you knowing it or not knowing it. So after a while, when the whole hype settles down, wherein it becomes mainstream, all the legacy systems have been covered, but all new systems coming in will always be fitted with IoT already. So if you visited a shop nearby, today you really see smart TV, smart AC, smart refrigerators, and everything smart. The new ones coming in. What does it mean? All these capabilities are getting integrated into systems that are being made new. So when the devices start coming like that, so then you don't really understand really is there or not, because it's more become more seamless and it is integrated into the way we live and then buy things and work in as well. So IoT definitely will be all over. So if you have a problem to solve, identifying whether it can be solved easily in an efficient manner, most affordable manner through IoT, I guess that's a better way to go, because things are going to get smarter whether you like it or not, right? The second element with that, why IoT, see, realizing a full product really requires quite a few things to be done. So one is design, engineering it, manufacturing it, and then when you put that to use, you need to do maintenance and repair as well. So today, with all devices becoming smarter, now you need smart solutions for design, smart solution for engineering, smart solution for manufacturing, smart solutions for maintenance, repair, and given one smart device, you need all of them together as well, which means it requires a whole network of things that are clearly required to work in tandem to make sure that all these things become smart and will be useful as well. In that situation, when the whole industry of adoption of IoT is happening, you actually have this value network also evolving very well, which also gives huge amount of opportunity for people to work with. You have an IoT solution for maintenance and repair, or you have a solution for engineering, you have a solution for design, you have a solution for manufacturing, or any specific elements in there. I think you see you can actually build a skill, capability, solution, and make a useful thing out of it. The third key element is that, okay, the whole industry, right? If you really look at the entire industry, which is any industry you take. So today, IoT is actually across industries. It's not going to be really restricted to only electronics, telecommunications, medical devices, etc. It's going to be everywhere around. But in those cases, everyone is looking at what value IoT can bring it to my industry. What value IoT can bring to my device, my solution, my system. So they're looking for it. So anything you do in any point solution as a value, I think it's going to be very well accepted there. And people look at how can we develop it together, because it takes a lot of time if I do it on my own, but if I work with an ecosystem, it becomes easier. So people are looking at partnerships and alliances that are critical to make sure that the solutions you build are going to be useful for them in their industry, and it helps you as well. And to support that, right, including governments and private parties and everywhere else, actually doing a lot of funding that happens to startups today is around IoT and IoT applications in a given industry segment. So there is a funding and access to resources, because large companies which actually make components and boards and everything else, they do offer a lot of do-it-yourself kits and also training kits for you to really access near production ready resources to really make sure that your solution sticks as well. Why do they do it? They're also looking at how to accelerate their innovation, right? And in the process, if you really build some solutions and proprietary things which can be patented, you have an opportunity to build IPs of your own, which actually can then encourage a good business interaction with the guys who would like to make out of it. Then you will be able to really make benefit of your effort as well as accelerate the innovation they are working with as well. So this in general, right, actually forces people to really look at, okay, which area to work with. So if you're starting on a clean slate and would like to know which industry you would like to go forward with in developing your skill or a solution, and you generally adopt the industry as well as the solution or a problem you're going to go after based on the potential there. So today, if you really look at all the levers out here, are not going to exist in every other element of technology solution you're looking at. So it'll be in minimal respect only. But when it comes to IoT applications to different industries, you actually have chance for being part of all these maturing levels of acceleration of innovation. So that's why I think IoT becomes a better choice to solve a problem. And IoT also presents good amount of opportunities for you to do the same thing as well. Right? Just to summarize, what happens is Internet of Things is not a new market. Like, okay, so cloud became a market, analytics became a market kind of a thing for people to start with. That's not going to happen. So Internet of Things actually is going to create more markets. So that's why we put more like it is maker of markets than a market by itself. That is one part. The second is every business in near future is going to run on Internet of Things. That is for sure. One or the other part of the business will be running on IoT, and soon you say that all of them are integrated and working fine. And as I said, when they become seamless and integrated, you will not start noticing them as separate part. So businesses start running on Internet of Things. You know what it means. Same time, every business also will have a lot more service components into it. Or companies which are actually doing only manufacturing or production and be done with it will start offering service-based businesses. Primary reason being you have the ability to control, monitor, automate minute aspects of your business or machines or integrated services out there. So you will see lot businesses transforming themselves more into a network service business. Say, for example, as I said, car rental company to actually have a Uber or a Ola company function, it is totally networked among car manufacturers, telecom service providers, media streamers, a drivers association, whatnot. All of that put together, working in tandem, is what actually makes a on-demand taxi business as well. So taxi is not like somebody owns a car, they have some free time, they'll just go and then stand, somebody will pick them. That is gone. More or less, it actually becomes a completely network business, which also isn't very global as well. So you may have an account in one place, but you move to another place, you actually carry the same account, your preferences, everything as well. So it becomes totally network service business as such. So IoT is really making many markets come up, and it's easy to learn, adopt, and make use of in a given situation as long as you know clearly which problem you're trying to solve. So definitely IoT presents opportunity to address really large, very lucrative, unsolved problems. So I think that is why I think IoT becomes a key element for all engineering students to really know, understand how to really build one, adopt it, and then move further as well. So that's fine. If you want to really go for an example of such and look at an opportunity, what can that be? Right? So let's say we choose water as a problem. And in that water, we actually say quality and quantity of water is what I would like to solve. So if you would like to solve a problem of quality and quantity of water availability in your area, say, you actually can figure out whether IoT can help there. And can IoT can build a solution which is meaningful. Plus, at the same time, can that be a business by itself as well? So just an example. Let's ponder it around. The first and foremost, whenever you choose an idea, whenever you choose an opportunity, or when you're actually finding out what to solve, the best is to find who is this for. Say there is water as such can be a big issue, but at the same time, you have to really figure out what solution are you building, which problem or which part of the problem are you solving. That depends on who is this for, right? The way businesses and industries look at it to answer this question is, who is my paying customer? So if I build a solution, is somebody going to use? And if somebody is going to use, are they willing to pay? That is the first question a business or an industry will ask. And they'll go further and ask, why will they really pay for it? Right? What makes them really pay for this particular thing? And the third question is, how much will they pay? So if you're trying to solve water quality and quantity problem in your area, and you want to really make a business venture out of it, and you're actually using a solution to build that, some of the elements that come into mind is to really figure out, okay, who is my paying customer, or at least who is the person who's going to use it, right? And then what are they going to willing to pay, and why are they going to pay for it, right? So these are the three questions you look at. If you try to answer that, right, when it comes to this water as a problem, so it can be at an individual level, it can be at a company or an enterprise level, or it can be for a government itself, right? But the problem you would like to solve, you have to first figure out who's this for. Okay, if they belong to one of them, then you actually choose that, and then actually try figuring out what are the boundaries of the problem, what are the issues associated with whatever you think is a problem, and then make use of what kind of choice of a hardware or a software and everything else that you would like to make up with. Then you go ahead and then design and build it. That's very, very important to find out who's this for. So when you present your idea, right, the first question you should ask, okay, we're trying to solve this problem, but who's this problem for, and who's the solution for? And if you really make it a product or a service or a solution, who's going to pay? And how am I going to really figure out, okay, they're going to really use it? And if anything required to be done out there, how are you going to do it, right? So these elements, I think you should keep in mind. Look at the same water as a problem. I'll show you the gravity of things that can be done out here. One of the solutions for water can be anything like this: flood watering and water level monitoring across the country. It can go to that extent, right? So only governments can do that, right? You actually have water level meters at different wells that pump, to our flow sensors for all our check dams and everything else, water ground level monitoring of water, or other elements that are actually creating issues around how different levels of activities in the weather helping or actually hurting the whole water system as well. It can go up to that extent. So one solution example, what you see out here, actually depicts all of that in one way. You can notice there you actually have several level meters, there are sensors, be it soil moisture monitor sensors, or rain gauge sensors, level sensors, flow sensors. You see the more of sensing that actually gets done. And that sensing feeds into a system. That system actually communicates back to another system, either on cloud or on other varieties of mechanisms. So continuous monitoring and learning of what's happening and learning that data with the rest of the things, something similar, you actually can trigger a lot of actions, either automatic or man-assisted, to make sure that you actually can really, really monitor flood water as well as any other ground or otherwise water level monitoring. So you can't think of making the whole solution work unless you start with a specific issue. So if your issue is to really find out, okay, I would like to assess the flow of water coming into a dam. So you start solving this as a small problem and then build a solution around it. Somebody builds a solution for the groundwater, somebody builds a solution for a very typical underground water system, wherein primarily say you have a bore well. How do you know the level of water in the well today? So there are cases of automatic pump on and off based on the power availability, also based on what is required for the particular crop you're looking at. But still we need mechanisms to find if the well has enough water to pump. So to get to do that itself becomes a problem. So if you integrate those solutions, or if your idea is to really work only on water, and that water is, these are the elements of water that I have to look at, and this is how I go build it, then you know this piece of it itself is a good opportunity. And then there are opportunities for integrating, there are opportunities for the whole solution, and there are opportunities for offering this as a service itself as well. So these are real solutions that are being used. I'm just giving you an example of how that is used for water alone, right? Look at other solutions of water. We know the smart cities and smartest city initiatives that are happening around the world. Our country also is looking at about 100 smart cities to start with. But the beauty is, whenever you actually have either 30 or 100 smart cities, over a period of time, maybe 8, 10, 12, 20 years, every city is going to be a smart city. The reason is, right from what water is coming through to what is flowing to what is being dispersed, and everything else can actually be literally managed, monitored, and made sure that that is in line with the requirements of what we are really working with as well. And then integrate that back to the weather conditions and weather predictions to make sure that the entire city, you can consider them to be living organisms themselves. So smart cities are not going to go away with just 30, 100 in India. Every city is going to be a smart city in one time or the other, and every small place is going to be smart by itself. So you see the kind of opportunities that will come in. So even if somebody specializes in actually only water, and their idea is to really build some water solution, both quality and say quantity, and then make sure that this is offered as a service, there are a huge amount of opportunities that are practically possible. One, then no one solution is going to fit all smart cities in the country or the world. So there are multiple things that are required to make sure that work. And you also need multiplicity requires integration of these things to work seamlessly between each other as well. So you actually have a platform and other approaches possible. So going back to the first slide, all the four elements and the supporting elements there actually play a large role to make sure that you can pick up a small narrative, build it to a local level. So this is what I was saying. This is very hyper local. Monitoring this particular valve is a very hyper local problem. And all these put together is a local problem. And then bring in whether it can become a regional problem. And then you do that across the world, it'll be a global thing that to solve as well. So a solution you actually identify to build for a problem should be actually as scalable as this one. And that is possible when it comes to IoT as a technology. If you choose it well, you can actually make it really go scale better. And this is the opportunity that's not going to go away soon. So if you want to really convert that little thing back to the enriching daily life story, so it actually goes to the connected cars. Cars actually know what actually they are doing, where you are, and what needs to be done for either your personal work or cars its own work and maintenance. It can be so extend to then move on to traffic, safety, security, tourism and hospitality, remote patient monitoring, smart grid, smart metering, retail, dispensing. Varieties of things are actually going to be very helpful to build solutions around to really enrich our daily life itself. And there are initiatives and projects going on across the world for this, and every company working in this space is actually working and trying to find out how they can use IoT to help them here. Same time, there are small companies, there are big companies, there are other companies who are working to really build either point solutions or integrated solutions to make sure that this area is actually very beneficial for them. Right? What that leads to is, as we talked about earlier as well, a lot of connectivity among all. So if you really look at healthcare and the care team as a product system, patient being in the center, everything else that are required for a patient to really recover and cure themselves, the multiple touch points and multiple agencies and multiple solutions required, all of them can come actually together as a system if enabled well, and they have their own sensing, they have their own communication, they have their own interactions with the rest of the system and other actions that can be automated to make sure the whole thing comes into play as a system. So more and more you see either a service like caring a patient or an automated car or automated water monitoring system, whatever the case may be, you will see system of systems. So first you should know how to build a system, subsystem, then a system, and system of systems together. So anything you build cannot be on its own complete. It has to work with the rest of the system to make sure that it is useful for the purpose you build. So, but IoT has a capability today, actually making every other dumb thing into a smart one. And if you chose the integrated system pretty well, there is possibility of actually making all of them work in tandem with one purpose of giving a better care, affordable care, and really the right time care possible for a patient. So that's how the whole solution can really bring up together. But let's look at another element of it, wherein this is till now we covered the problems we know and the problems that have been being solved for a varieties of reasons in varieties of ways. If you look at it, there are other areas where this will enter. This is just to give you an idea of how IoT is spreading its wings as well. Right? So let's look at an example of a personal seismograph. So a seismograph is a device which actually alerts you if there is an earthquake. right? So mostly what happens when an earthquake happens, some government department has to sense what is happening out there, measure it, figure it out what the whole thing is all about, and sends information to people to vacate and everything else, right? So what if we actually had a personal seismographic, which is a small device of the same size as what you see in the picture, available, and you actually install at your home, and if it is around area which is known for earthquakes and all of that, this can actually sense alert and also make sure that the whole message goes back to everybody else around and who needs to be taken care, to make sure that the whole thing works more as a personal system than waiting for something to really come through through other channels of finding out what happened, right? So this actually enables many things. One, how does earthquakes happen, how the earthquake spreads, and what happens. So a lot of data that gets generated, collected during the course itself can actually trigger a lot more action seamlessly in real time itself. So can people really affordably pay for it, right? But this kind of solution, if you really see here, is roughly about $30. So $30 device, which actually helps you save lives in case of an earthquake, will definitely be very useful personal device at homes, offices, wherever, in areas where you really know that earthquake is going to happen, or at least the area is prone to earthquakes of sorts. So what is happening is, with devices capable of sensing, capable of communicating, capable of analyzing, and capable of taking action, you're actually converting areas like earthquake, problems like earthquake, help more or less being actually addressed by the community itself. So it is no more going to be just a government problem. It actually will be very useful individual problems to solve, and these devices can become a real big tool to really help us do that particular thing as well. So that is the level of real personal experiences, usefulness people can really think of making out of IoT as a solution applied to solving this problem of identifying and notifying earthquakes in real time. And as you know, right, so quakes travel at one speed, mostly 100-kilometer out or so, but the tweets and other messages between phones and everything else travel much higher time. So the overall experience of using it, affordability of using it, I think will make an opening for solving several other problems that are not hitherto solved or thought of solving at whatever level, be it at a personal level or at a locality, at the regional or the global level as well. So those things are going to come, right? Apply some all these things in a similar fashion to the water quality and quantity problem we said, right? So we first have to be very clear that it should be for a whichever segment of the market we are addressing. Because if you're building it for a government, you need to build it differently. But if I say that, okay, my interest is to build it for semi-urban people who will pay only for net consumption. So that is how you can really build this up. So what I mean by that is, we saw that you can harvest water, we can measure the quality of water, also sense what is happening, where the water is there at all or not, and then put it back to the system. Like the power grid, where today you can actually harvest a power and then put it back to the grid, where you are going to benefit by really paying only for what you consume as a net consumption. Say you produced 100 units and you consume 200, you pay only for 100. Likewise, we can actually look at harvesting water, feeding it back to the system back again, using what we like as well. So then we pay only for the net consumption. So that is the kind of solution we can build when it comes to IoT business around water quality and quantity problem itself. Let's see how we can really narrow it down a little further, right? How do I build it, right? How exactly I'm going to really build this and build any solution around IoT, and what should I be doing? See, whenever we actually build a product or a solution, there are three aspects that become very critical. So these aspects are core purpose of the product, the user profile, and deployment scenario. Tell you what they are. So core purpose is the purpose for which you are building that particular product or a solution. So let's take an example of a pen. If you're making a pen, the core purpose of pen is to just write, right? The pen has to write. That's the core purpose. Everything else comes secondary. Next is, who is this pen for? Is it for a small kid who is learning, or an engineering student, or a professor, or an executive? Who is the profile of the pen? Because if you go to a market, you will see varieties of pens. They're all actually targeted towards a particular user. So that defines the look and feel of it, how it's going to look, how it's going to be really the materials you're going to use, and everything else put together defined by the user profile. Third is the deployment scenario. How is it going to be used? Where is it going to be used? What is the deployment? Am I going to use this particular pen on paper, plastic, or board, underwater, right? Or in this space? Where am I using? So deployment scenario actually decides so many things, right? In terms of how the whole flow should work, or how the engineering should be done internally. So internal engineering happens because of the deployment scenarios that changes from one to one. So as you said, water level monitoring is or what we are trying to do. Then how are we deploying? Is it for a bore well or an open well? Is it for a sea? Is it for ground? Where is it for? So that actually defines a lot of engineering aspects of it, right? And the user profile decides, okay, who's going to use it. That also defines the look and feel, the business, the culture, and everything else that are required for that as well. So this is very simplistic rule for really building any product or a solution, which actually is critical for a user part. So core purpose, user profile, and deployment scenarios are the three elements that you always worry about. But if you really look at IoT, same thing. You need a core purpose. Why are you building it? And a user profile. Who is that for? And how is it going to be deployed? This is very, very important. But along with that, since you actually have sensing, communication, right, and some amount of analytics and action taking and everything else required there, science, engineering, business play a big role. But at the same time, the culture is another aspect you need to consider when you are actually trying to use IoT for a solution out here. The reason for that is the way people were using today, till today, a particular thing solving a problem will actually be changed drastically differently. Say, for example, this water level thing, what you're talking about. So today, water level measurement may be done in varieties of ways, right? But the moment you actually say, oh, I use an ultrasound level detection device, the whole culture of how you look at water is going to really change, right from the user to the way it is deployed and how it's going to be deployed in the larger scheme of things. So what happens is when you do IoT, be it a healthcare solution, be it a water level condition, whatever the thing may be, the user profile and the attached new changed behavior because of the device what you're building, or at least the capability you're building to the device already existing, actually decides whether it is going to be successful or not. So whenever you're building an IoT solution, whenever you choose a problem where you can relate, choose a problem that actually is meaningful to solve at a hyperlocal level, and then at a local level, and then scalable on its own. And at the same time, look at these three parameters. What's the core purpose of whatever I'm building? What is the user profile? What's the deployment scenarios I have to consider? And make sure that you cover the cultural impact of whatever you're trying to build as well. Because in any example I actually quoted now, same thing happens. Even machine becomes intelligent enough to really look at how long the consumable is going to last and actually order and make sure that the whole production process works. You see how the cultural impact going to be around the guys who are really working on today. They have to change the way they work as well. So the culture becomes a very serious aspect to consider in terms of IoT as an implementation solution for a problem that you have chosen. Right? That is one. Really cover this. Okay, with all this, how do I really build it? So if you want to build, as I said, culture becomes one aspect which is very critical here to test whether it is going to be accepted in the market or not, and also to make sure that you learn while you build. There are varieties of mechanisms companies actually adopt today to really build a IoT solution or some solution which actually touches the IoT part of it. I'll give you one example here. Say we talked about a road accident as a case, right? So if somebody is working on road accident detection or anything which requires assistance on the roadside, and automatically either transmits data or information to either their family or for the workshop, cops, a hospital, whatever the case may be based on that. To really do that, okay, it has definitely science, sensing part, engineering, and all other things. Beyond that, you also should know whether people are going to adopt it? If so, how are they going to adopt it? What is the best position to put this device in the car, right? How much are people really willing to pay? So to test that, right, this company went ahead, actually built a prototype and actually put it up on a crowdsourced environment, wherein they said, okay, this is what we're building, and you can pre-order it, participate in how we build it, so that you actually use it as well as give us a feedback to strengthen it better. So the beauty of these things today is you can build, if you have a problem which you're very clear of, a solution that actually can be tested in the market sooner than later. Then you can actually have the power of crowd to really help you then deep density of pockets that are required earlier to really innovate. So we have seen solutions wherein people have spent or at least built solutions which are just 2,000 rupees to completely automate irrigation for say 20-acre property. So there are solutions like that people have built. So if you are very engineers and you're actually really looking at solving a problem without compromising on efficiency and the effectiveness of it, there are ways to do it today. So why am I stating this here is that you will be participating in this particular challenge. You come with your idea, solution, etc. Maybe 3 or 4 of you may win the whole competition. But the thing is, if your idea is strong, you actually are proceeding further down, I think you can actually go ahead and build that into a particular solution of interest for whichever problem you actually started with as well. So you don't have to leave it in the middle. You can take it further, build it, and there are opportunities today to build your own empire around it, or at least to go and then make sure that that becomes part of another existing or a integratable system as well. So at the same time, right, in the same line, if you see, there are a lot of companies today. We call it corporate venturing. The big companies like Google, Cisco, and every other company which is interested in external innovation, as we call it, wherein they're innovating with others. So they choose a method of either startups or actually go with academics or other challenges and competitions like this one. Actually make use of what you guys solve. So if there is one single problem, like the water problem we talked about, if all of you solve that water problem, there is possibility that there are 200 different solutions that will come. So whichever is a better, that can be used. One. The other one is the same solution is not suitable for every place. As I said, the deployment scenario defines exactly how you can really go ahead and then you make use of this, right? So companies actually support either via the startup route or other routes to make sure that they also benefit and especially encourage disruptions within their own organizations and product lines due to working like this. So if you build solution to a good problem, a good solution to a good problem, I guess there are a lot of support system available which you should make use of today to really make sure that the solution reaches the potential of what you're building it for. So the third one is there are open social innovation challenges. Governments around the world put it together as well. So for example, it may be a very specific solution required for one city and a smart city challenge. That point in time, as I said, problems are always hyperlocal. Solutions can be as global as possible. So you can actually build solutions that matter to cities around you, places where you live, and you have opportunities there to really build them into a level where it can get integrated into solving a serious problem that is ahead of the particular locality out there, or challenges governments and other industries are putting together to make sure that it actually helps in with your solution that you're putting it up as well. So there is today a lot of power in the crowd participation. There are a lot of support from corporates and other initiatives, and there are a lot of sharing of ideas, as we call it as Creative Commons, wherein a lot of people share their IPs, their original designs to make sure that the adoption becomes much, much higher. So if you end up building a solution which you think is only a part of a solution but is a very good solution, you can actually share it with the rest of the world for them to really make use of it, so that you learn, you gain, they learn, they gain, and at the same time the whole journey of making continues as well, right? So the principle here is, when it comes to IoT and adoption of IoT as a solution for a problem you want to solve, goes around collaborative, very co-creative and coexistent approach. As I said, one universal standard, one universal solution, one universal product is not going to help solve hyperlocal issues. So it'll always have to coexist with the old and new. There'll be co-creation possibilities for everybody. And as I said, the crowd and Creative Commons and corporate ventures and everything else actually helps you do what you would like to do with IoT as a solution for a problem you've chosen. The trick is you need to choose a problem worth solving and build a solution which is actually compelling, not to ignore, so that you actually get the traction required to build it into a whole full suite of solution, and also maybe if required and if you're willing, into a business by itself as well, right? So if with this information, if I have to revisit the opportunity we talked about, it may sound something like this. Opportunity may be building an IoT-led business that solves water quality and quantity problems for semi-urban Indians who will be included in the entire value chain from supply, distribution, maintenance, usage, and may pay for only net consumption. You see, what I started off saying, okay, look at an IoT solution for solving water quality and quantity. With what we gained as an insight, we can actually go ahead and then build entire value chain wherein you can include them in every process of it. Because if I'm harvesting, you're actually collecting, you're supplying, you're distributing, you're also actually maintaining your own harvesting system, and you're using it. And since you're using it, also you're using the public system connected to it, you may only pay for the net consumption. So that is the level you can really take to, right? So that's all fine. How do I really develop and expand it on this particular opportunity, and how do I really scale it, right? I want to just repeat what I said in the beginning. There are in the market, in the industry, these maturing levers of acceleration for innovation are playing very, very well. So if you can build something which you can really sell on your own or show it to others to really help you scale it up, I think your value, what you bring, amount of partnership alliances possible, as I said, the funding and other resources available, potential to really make an IP or a patent out of it, and align with other businesses and everything else that are actually going through to really make use of it. I think there's one very classical route that may be applicable for all of you guys to really make sure that, okay, you build on whatever you're developing today, make it complete, make it really compelling enough so that you actually become part of using these levers of acceleration. Others are really using it for their internal expansions as well, right? So overall, you can pick up a problem, make sure that problem is worth solving, and build a solution which is very compelling. Then also wait it around, okay, who is this for? Who's going to pay for it? Who's going to use it? Why do they really pay for it? Is there something in for them to really support you or use you? That actually does a litmus test of how useful this is going to be. Make use of that to really define your problem statement. So your idea or a problem statement sound something like this for the water opportunity we looked at. So it can be building an IoT-led business with an intuitive and inclusive platform, connecting communities across localities that solves water quality and quantity problems for semi-urban Indians who will be included in the entire value chain from supply, distribution, maintenance, usage, and may pay for only net consumption. So this becomes the larger picture of what we started off with, saying that, okay, can we really build something, an IoT solution or IoT business for water quality and quantity problems? Either you start like that and expand, come to a narrow level here. And with this particular statement, I say, okay, to start with, I would like to see if I can do wireless water level monitoring possible first. And then you can look at water metering, you can look at several things that are required here to make this work. So the moment you write this down and then paint a picture of it, you can start small, but actually scale it up to make it work for everybody as well. So this is how you actually look at an opportunity, look at an idea around IoT, and actually help build your own case around it. So this is just a gist of what is possible with IoT and the kind of opportunities that lay either on a technology level, business level, operation level, either for efficiency, either for experience, or for empowerment of sort. End of the day, simple four elements supported by another infrastructure actually is giving you an ability to really go and solve really large lucrative problems. Okay? That is possible. So in this context, right, it's up to us to really create something remarkable. So in this challenge, while you're participating, I think you have an opportunity to really do something like that now. Wherein, I repeat again, choose a problem worth solving, find how you're going to solve it, and the solution should be compelling and innovative so that it actually stands out among the rest and actually helps you build a solution which is meaningful. Because while you do this, there are two, three things that happen. One, you will learn engineering skills that are required to make something on your own. So that is our intention. Second, you get exposed to IoT as an upcoming technology stream which actually has a lot of potential for jobs of the future. That is one. Right? The third, if you're working in a team and working with everybody else and managing your classwork and everything else, you learn managing multiple conflicting priorities, which is going to be a very useful soft skill which can never be trained otherwise. So this becomes a skill building exercise. This becomes a technology exposure exercise. More than anything, making skills which are very, very critical for future of jobs. I think this is an opportunity for you guys to participate well. So my earnest request is make use of this, do well, and really make this remarkable for yourself and everybody else as well. Thank you.